So we're going to look at, we're going to make a reference sheet here that you're going to keep this with you when we're working on solving quadratics. So first of all, what does it mean to solve a quadratic? Well, that's kind of a shortened, paraphrased set of directions. When we say solve a quadratic, we really mean a quadratic equation. And so when we say solve a quadratic, it means we have an equation So it's an equation because there's an equal sign and the highest power of x is 2. So that would be an example of a quadratic equation. So we want to solve this, which means we want to eventually get to x equals, say, 2 and -3 or something like that. And there can be up to 2 answers in a quadratic. There can be up to 2 solutions in a quadratic equation. Here are some examples of what are not quadratic equations. Sometimes it's good to compare and contrast. All right, so this one, 2x squared plus 3x plus 7, that is not a quadratic equation because it's not an equation. Where's the equal sign? You can't solve that. It's an expression. X plus 3 equals 2x minus 7. That is an equation, but it's not a quadratic equation because the highest power of x is 1. We would call that a linear equation. X cubed plus 2x squared plus 8 equals 0. That would be called a cubic equation because the highest power of x is 3. So when we want to solve our quadratic equations, it has to have an equal sign and the highest power of x needs to be 2. So that's what it means to solve a quadratic. Why is this significant? Well, if we think back to graphing quadratics, if I have the quadratic function y equals x squared plus 3x plus 2, what if I want to find the x-intercepts? That's why we're learning how to solve quadratics, one of the uses. There's other uses. To find the x-intercepts, we know that the x-coordinate is 0, but we need to know what our y-coordinates are. I'm sorry, the other way around. We know our y-coordinates are 0. We need to know what is our x-coordinate. We're trying to find where this quadratic crosses the x-axis. And I want to say again, I said it quickly before, it could be as many as 2 times. The quadratic could have 2 solutions, 1 solution, or no solutions. So how do I find x-intercepts? Well, we plug in 0 for y, and now we have to solve for x. So that's why it's significant. One reason is we can find x-intercepts this way. All right, so now we're going to look at how do we actually solve quadratics. So example 1, what if the quadratic were in vertex form? If we had y equals -2 times the quantity x plus 3 squared plus 20. So if I wanted to say find the x-intercepts, I would plug in 0 for y and solve. So I'd just like to show you where this comes from, why there's a 0 plugged in there. So now that's what we see here. Okay, so let's say we're looking for the x-intercepts. How do we solve for x when it's in vertex form? That one's a little bit easier to do than the others. I'm trying to find a highlighter. We'll use this gray one. X appears only once in the equation. So that's going to be what we usually do. It's called isolate the variable. That means get x by itself. So the method we'll use here is isolate the variable. Remember, that's in fancy math speak. What that means is get x alone by itself on one side of the equal sign. So if I want to get x by itself, well, first of all, it's part of this bigger chunk of stuff, squared. So I want to get that by itself. So what I'm going to do is I'm going to subtract 20 off both sides of the equation. So I'll get -20 equals -2 times x plus 3 squared. So again, x is inside this big chunk of stuff here. So I want to first get this. I'll do it in purple. I want to get that by itself. So now I want to get rid of times -2. So I divide both sides by -2. And I get 10 equals x plus 3 squared. Now I want to get x by itself. So I'm just going to recopy this because I need some more room. So I've got 10 equals x plus 3 squared. So if I want to get x by itself, here's the part where I can break down the square. The way you undo the square is to square root both sides. So I get on the left side, 10 is not a perfect square, so I'm going to leave it as the square root of 10, and it's going to be plus or minus. because when you square root a number, there's two versions, the positive and the negative. On the right side, the square root of squared, right, the purple square root and this square cancel, and I get x plus 3. So now really this is like two equations. I'm going to write them on the side here. You don't have to do this, but I do want to point out that it's really like having two separate equations, and that's why we're going to get two answers. Because of this plus or minus, it means I have a negative square root of 10 equals and a positive square root of 10 equals. Now square root of 10 is just a number. It's irrational. We're just going to leave it. Just like in geometry, when you would find the area to be 4 pi, you left the pi in there. Okay, so we don't typically like writing two equations, so we just leave it as one like I do right here, but I put a plus and minus in front. And remember, this plus or minus right there means that it's really two numbers. All right, so now if I want to solve this equation for x, I'm looking at this side of the equation here, x plus 3. I want to get x by itself. I subtract 3 off of both sides of the equation. So on the right side, I'm left with x. On the left side, I have negative 3 plus the square root of 10 and negative 3 minus the square root of 10. So that is our final answer. You do have to consider simplifying the square root of 10. Now in this case, it's already simplified. But in other cases, you might be able to simplify that to something like 2 times the square root of 5 or something like that. In this case, it doesn't simplify, so that's my final answer. And remember, that's really two answers. Negative 3 plus the square root of 10 and negative 3 minus the square root of 10. Those are my two answers. And that's how we do it if it's in this vertex form. What if it's in standard form? So again, remember, this might have been y equals negative 2x squared minus 4x plus 30. And we wanted to find the x-intercept, so we plugged in 0 for y, and that's how we arrived at this equation. When it's in standard form, isolate the variable is not going to work. Because x appears more than once. X squared and x show up more than once in the equation. So how can I get x by itself if it's showing up twice? I cannot do that. This method, to solve this, we're going to call this method the zero product property. And we know to do it because x is showing up twice. So this is like the opposite of getting it's like a different method than getting x by itself, isolate the variable. It's sort of like the opposite thing, the zero product property. So what that means is you got to make the thing equal to 0, so get everything else on one side, which has already happened. And now the right side that has all the x's in it, our goal is to turn it into a product. That means we have to factor this thing. It is not a product. This is currently not things multiplied together. So first I noticed that it's got a common factor of negative 2. So when I divide out a negative 2 out of each spot, right, I write my common factor here, and then inside the parentheses I divide everything by negative 2. So I get plus 2x minus 15. Now I can keep factoring. The negative 2 goes along for the ride, and the x squared plus 2x minus 15 becomes an x and an x. And I get two numbers that multiply to negative 15, but add to 2 are going to be 5 and negative 3. Now I can apply the zero product property because I have products. Three things times each other, they make a product equals 0. So when x plus 5 equals 0, that's going to be a solution, or when x minus 3 equals 0, that's going to be a solution. Because if I can make, say, this whole part 0, because it's multiplication, negative 2 times 0 times whatever I get will always be 0. And another solution will be if I can make that one 0. So that's what I do. I write each part. I want that x plus 5 to be 0, and I want x minus 3 to be 0. If I solve those, I get my two solutions. Okay? And then the last one is when it's in intercepts form. That's the easiest one. It's just like we're using the method is zero product property. It's just like the one we just did, except they did the hard work for you. It's already been factored. So I can go straight to the zero product property. Meaning I've got a product, three things times each other equaling 0. So if I make each part equal to 0, and solve, I'll get my solutions. This one, keep in mind, can never be 0 because it's always negative 2. So I don't make an equation like negative 2 equals 0 because I can't solve it. It doesn't have an x in it. So if I do x, I subtract 4. And here, if I get 3x minus 10 equals 0, I'm going to subtract, or I'm going to add 10 to both sides. Then I'm going to divide by 3. Those are my two solutions. So once you have it factored and equal to 0, you set each factor equal to 0 to solve. That's what the zero product property tells us. It allows us to set each factor equal to 0 to solve it.